Now let us see the students of 12th standard, new chapter, chapter 7, alternating current circuits. So actually you have to study about those circuits with which AC voltage is applied. This is most important chapter in physics. The first topic is AC voltage applied to resistor R. As you know, AC voltage means alternating voltage. Alternating voltage, that means this voltage goes on changing or goes on varying with sine function. So as it goes on changing according to sine function with time, it do not remain constant at any moment. It go on changing according to the sine function. And DC voltage will always be constant at every moment. So here the AC voltage and symbol of the source of AC voltage is like this one. Here it is written V equal to Vm sin omega t, and this source is connected with resistance R. For the first half cycle, first terminal is positive, second terminal is negative. For this next lower half cycle, the first terminal is negative, second terminal is positive. From positive terminal, current will come out and come to the negative end. Then for the second half cycle, current will come out from this positive terminal and enter into these sources. That means the current is flowing for this first half cycle in anti-clockwise direction. For this second half cycle, the current will flow in clockwise direction. So these go on changing alternating. And that's why it is alternating current and alternating voltage is there. So resistor R is connected to the source of AC voltage, and AC voltage is given by either V equal to Vm sin omega t, or it can be given by the equation V equal to Vm cos omega t. Here we are accepting source of AC voltage V equal to Vm sin omega t. Well, what is Vm? So Vm is said to be this kind of maximum voltage. And as you know, in case of oscillating pendulum, you know the maximum displacement towards the right side or maximum displacement towards the left side is known as amplitude. So from this point of view, this Vm is maximum voltage, or you can say amplitude of oscillating potential difference, and omega is angular frequency. And omega is angular frequency, that means omega equal to 2 pi, where f is frequency. If I say frequency is 1, it means what? This cycle complete in 1 second. If I say frequency is 10, that means what? In 1 second, 10 oscillations, 10 times cycles are taking place. If frequency is 5, that means within 1 second, 5 times oscillation, that is 5 times cycle taking place. So omega is angular frequency. According to Ohm's law, now we can determine the AC current. The AC current flowing through this circuit equal to V upon R, that is Vm sin omega t upon R, but we take this Vm upon R as maximum current, or you can see this amplitude of current. So this can be written as I equal to Im sin omega t, where Im equal to Vm upon R is maximum current, or you can say it is current amplitude. Now here what happening? According to this graph, this black line indicates the graph of AC voltage versus time. This red line indicates the graph of AC current with time. तो here 0, देखिए ध्यान से, वोल्टेज की वैल्यू जब 0 है, करंट की वैल्यू भी 0, at an angle omega t equal to pi by 2, voltage becoming maximum, current becoming maximum. At an angle omega t equal to pi, current becoming 0 and voltage becoming 0. That means this both go on changing simultaneously in such a way that when voltage maximum, current maximum. When voltage 0, current is 0. Now in reverse direction, when voltage becoming maximum, current becoming maximum, and at omega t equal to 2 pi, when current is 0, voltage is 0. That means दोनों एक साथ maximum होते हैं या दोनों एक साथ 0 होते हैं. And that's why it is said to be the graph of AC voltage and AC current as a function of time are shown in figure, and this AC voltage and current are said to be in phase. are said to be what? In phase with each other. Is it clear? दोनों एक ही मोमेंट पे मैक्सिमम होते, दोनों दूसरी कोई एक मोमेंट पे जीरो होते, यानी कि दोनों की वैल्यू मैक्सिमम एक साथ, दोनों की वैल्यू जीरो एक साथ, किसी भी अलग अलग टाइम पे मिलता है, तो इसको क्या कहते हैं? वोल्टेज एंड करंट आर इन फेज विथ ईच अदर. देन फ्रॉम दिस ग्राफ नाउ हियर फॉर दिस फर्स्ट हाफ साइकिल, ये सारी पॉजिटिव वैल्यू ऑफ वोल्टेज, पॉजिटिव वैल्यू ऑफ करंट. फॉर दिस सेकंड हाफ साइकिल सारी नेगेटिव वैल्यू ऑफ वोल्टेज एंड नेगेटिव वैल्यू ऑफ करंट. तो फ्रॉम दिस पॉइंट ऑफ व्यू यहां से फॉर दिस फर्स्ट हाफ साइकिल के लिए जितनी पॉजिटिव वैल्यू है, ऐसे ही यहां पर नेगेटिव वैल्यू है फॉर द सेकंड हाफ साइकिल के लिए. तो ये सबका सम पॉजिटिव एंड नेगेटिव आपको क्या मिलेगा? जीरो फॉर वन साइकिल, यानी कि फॉर वन पीरियोडिक टाइम ऑफ ऑसिलेशन. तो द सम ऑफ द इंस्टेंटेनियस करंट वैल्यूज over a one complete cycle is zero. So the average current is also zero. तो अब करंट एवरेज करंट जीरो है, तो इसके ऊपर से ये नहीं कह सकते कि पावर कंजम्पशन इज जीरो. तो however the average power consumption is not zero. Why? Because power is given by what? I square into capital R. तो जब पॉजिटिव वैल्यू ऑफ करंट है तब पावर I square into R, नेगेटिव वैल्यू ऑफ करंट है तो I square, तो स्क्वायर किसी भी नेगेटिव वैल्यू का पॉजिटिव ही होता है, इसलिए I square R कैसे मिलेगा? पॉजिटिव. That means the power depends on I square, which is always be positive, whether the current value I is positive or negative. So here average current is zero, even though the power consumption in this circuit is not zero. It is equal to I square R, क्योंकि पॉजिटिव वैल्यू ऑफ करंट का भी स्क्वायर पॉजिटिव होगा एंड नेगेटिव वैल्यू ऑफ करंट का भी स्क्वायर पॉजिटिव ही होगा. Then, thus when AC current passes through the resistor R having a resistance R, then as we know power P equal to I square R is what? It is a Joule heating effect. So Joule heating effect I square R takes place, and so electrical energy which is supplied by the source of AC voltage is converted in the form of heat energy when it passes through the resistor R. So electrical energy will be dissipated in the form of heat energy. Now we talk about the instantaneous power. The instantaneous power dissipated in resistor is P equal to I square R. What was I? AC current I. AC current I is given by Im sin omega t. So Im sin omega t का whole square into R. That can be written as Im square into capital R into sin square omega t. Now average power consumed over one cycle, P bar equal to, so this is the symbol of average, average of I square R equal to I की वैल्यू हमने पुट की Im sin omega t, तो average of Im square R into sin square omega t. But here Im is being maximum current remaining constant, R resistance constant come outside the average symbol. So average power P bar equal to Im square into R into average of sin square omega t. Now mathematics comes. We remember average of sin function omega t over a one periodic time is always 0. But the average of sin square omega t over a one periodic time is equal to 1 by 2. So substituting this is 1 by 2, the average power equal to 1 by 2 Im square into R. So this is the average power consumed in AC circuit having a resistance R. But we know that what is DC power? अगर ऐसे AC वोल्टेज के बदले में बैटरी लगाई होती 1.5 वोल्ट का ड्राई से लगाया होता तो आपको DC पावर मिलता. तो वो DC पावर इक्वल टू क्या? कैपिटल I स्क्वायर इनटू R. If you compare this equation of DC power with this average AC power, then you can write this I square equal to क्या? 1 by 2 Im square. So we get I square equal to Im square by 2. It means this DC current I equal to Im upon root 2. So here you can say that this DC current I is equivalent to Im upon root 2. And this Im upon root 2 is known as root mean squared current. So this I equal to Im upon root 2. So this Im upon root 2 is called root mean squared current. And this root mean squared current is symbolized by small I suffix RMS. So this capital I equal to Im upon root 2 is called root mean square current, or it is known as effective current, and it is equivalent to DC current I, and that's why this capital I equal to Im upon root 2, Im upon root 2 can be replaced by the symbol of I suffix RMS, and it can be read as root mean square current, and this root mean square current is Im upon root 2. So thus IRMS equal to DC current I equal to Im upon root 2 equal to 0.707 Im, 1 upon root 2 की value. In terms of capital I equal to IRMS, the average power is denoted by simply P, and therefore this average power P equal to P bar equal to 1 by 2 Im square into R, or you can write that P is equal to capital I square into capital R. Now similarly, we talk about the root mean square voltage. So similarly we denote root mean square voltage or effective voltage by the symbol capital V suffix RMS, or simply capital V is there. Therefore this VRMS, तो जिस तरह से IRMS equal to Im upon root 2, इसी तरह से VRMS equal to Vm upon root 2. But we know that Im equal to क्या होता है? Vm upon R. So you can write Vm is equal to Im into R. Divide by root 2 करो दोनों साइड से, तो Vm upon root 2 equal to Im upon root 2 into R. So this implies, so this is replaced by VRMS symbol, this is replaced by IRMS symbol. So you can write it, so this is VRMS equal to, this can be written as small IRMS, not capital I, be remember. IRMS into R. We remember this is just like Ohm's law. So VRMS equal to IRMS into capital R. We know that in our houses the power comes is the AC power. We know that the household line voltage, और वो AC वोल्टेज कितना होता है हर एक के घर में, इंडिया में पूरे कितना होता है 220 वोल्ट फिक्स होता है, और ये 220 वोल्ट कौन सा है? 220 RMS वैल्यू ऑफ AC वोल्टेज, जिसकी पिक वैल्यू कितनी? तो यू कैन डिटरमाइन बाय यूजिंग दिस इक्वेशन, कौन सा? VRMS इक्वल टू Vm अपॉन रूट 2. तो Vm इज सेड टू बी मैक्सिमम वोल्टेज, इट इज सेड टू बी एम्पलीट्यूड, और इट इज सेड टू बी द पिक वैल्यू ऑफ वोल्टेज. तो दिस पिक वैल्यू ऑफ वोल्टेज Vm इसके ऊपर से आएगा इक्वल क्या? रूट 2 इनटू VRMS, एंड रूट 2 यानी 1.414, एंड RMS वोल्टेज कम्स टू आवर हाउसेस is 220 equal to कितना मिलेगा? 311 volt. Then this equation of power loss, power P equal to capital I square into R, can be written as in three ways. The power loss P is equal to V square upon capital R, or you can write VRMS square upon capital R. Second is power P equal to current into voltage. करंट मतलब कौन सा करंट? ये AC करंट और ये AC वोल्टेज. तो AC करंट मतलब रूट मीन स्क्वायर करंट मल्टीप्लाई बाय रूट मीन स्क्वायर वोल्टेज. अब यहाँ पे दूसरा इक्वेशन जो I स्क्वायर R होता है, तो यहाँ पे भी क्या मिलेगा? I RMS का स्क्वायर इनटू कैपिटल R. तो these are the three equations of power loss in the form of current I square RMS into R, in the form of voltage power P equal to VRMS square upon R, and in the form of product of current and voltage is IRMS into VRMS. Now let us see the example 7.1, which is given in your textbook. I read it. A light bulb is rated 100 watt for a 220 volt supply. Find A, resistance of the bulb, B, peak voltage of the source, and third is the RMS current through the bulb. So actually what happening when you purchase any kind of the bulb, it means any electrical device. On such electrical device, two things must be written. Number one, how much be the power of that electrical device which it can supply or it can consume, and second is VRMS voltage. For every electrical device, VRMS equal to V equal to 20 volt is fixed. If the electrical device have been constructed in India, then this voltage is always be fixed on any electrical device. The power may be different, 100 वाट का बल्ब हो सकता है, 40 वाट का भी हो सकता है, तो यहाँ 10 वाट का भी हो सकता है। तो यहाँ पे पावर कितना लिखा है 100 वाट। एंड आपको क्या फाइंड करना है, एक बल्ब का रेजिस्टेंस। तो पावर P इक्वल टू V स्क्वायर अपॉन R, therefore R is equal to what, V square upon P. Why you use this equation power P equal to V square upon R? Because in our houses all the connections are in parallel, and as they are in parallel, तो पैरेलल के लिए आपको यहाँ पे कौन सा इक्वेशन यूज करने का, पावर P इक्वल टू V स्क्वायर अपॉन R, बिकॉज फॉर एवरी पैरेलल कनेक्शन वोल्टेज रिमेनिंग कांस्टेंट। जबकि सीरीज में होगा जितने इलेक्ट्रिकल डिवाइसेस, तो अक्रॉस दैट वोल्टेज अलग अलग होंगे, लेकिन यहाँ पर क्या है, वोल्टेज रिमेनिंग कांस्टेंट। दैट्स व्हाई यू हैव टू यूज द इक्वेशन ऑफ पावर इज इक्वल टू V स्क्वायर अपॉन R। Therefore R is equal to V square upon P. 220 square upon 100, answer is 484. Now we want to determine ये 220 वोल्ट जो RMS वोल्ट है उसमें पिक वैल्यू ऑफ वोल्टेज कितनी, मैक्सिमम वैल्यू ऑफ वोल्टेज कितनी, एम्पलीट्यूड ऑफ वोल्टेज कितना, दैट इज कॉल्ड पिक वोल्टेज। तो VRMS इक्वल टू VM अपॉन रूट 2 इस फॉर्मूला। तो VM इक्वल टू क्या, रूट 2 इंटू VRMS। आंसर इज 1.414 मल्टीप्लाई बाय 220 इक्वल टू 311 वोल्ट। Then you have to determine RMS value of electric current flowing through bulb. So now you can use the equation of power equal to IRMS VRMS. Therefore IRMS equal to power upon VRMS. So 100 upon 220 you will get the answer is 0.454 ampere.